Welcome back to the Deep Dive. Today, we have a really dense and super specific stack of sources in front of us. We're looking at the Lote Notes, November 2025 newsletter.
And it's a fascinating collection.
It really is. We're talking about the absolute leading edge of risk. It covers everything from physical safety regulations and next-generation energy hazards all the way to security mandates and the sheer terror of insecure digital infrastructure.
Yeah, it's a lot.
So our mission today is to cut through that complexity. We're going to try and quickly distill the key themes, the key insights you need to know, spanning physical compliance, emerging risks in, say, the net zero economy, and the legislative framework that's meant to protect our critical national assets.
And that mission, it's really rooted in the core philosophy that the CEO, Dr. Mar Maghrabi, lays out. His message is all about continuous innovation, about the absolute necessity of challenging convention to create a safer world.
A more secure world.
Exactly. And what's so fascinating is this intellectual tension that seems to be driving the whole newsletter and also their recent second Lote Technical Conference in Sydney.
What's the tension?
On one hand, you have this fierce commitment to deep, old-school, evidence-based expertise, just knowing your stuff inside and out. But on the other hand, they're grappling with how to rapidly embrace generative AI and automation.
While being careful.
Yes, while remaining, and this is a direct quote, mindful of the limitations and risks inherent in these tools. So it's this foundational debate, How do we marry human judgment with machine speed?
That balancing act is a perfect lens for this deep dive. Let's start right on the ground, connecting that high-tech mission to the gritty reality of physical safety and compliance. We have to begin with the hands-on work of site inspections.
Right. And Yahya El-Halak's contribution makes it clear that Lote sees their safety inspections as way more than just, standard checklists. They're described as immersive experiences.
Immersive? How so?
Well, they combine this rigorous, evidence-based assessment with a deep, almost preservationist appreciation for the built environment itself.
And when you look at the portfolio they're talking about, from high-density community facilities and iconic Sydney structures all the way to these massive, complex projects like the snowy Hydro 2.0 tunnels.
Yeah.
You get why that rigor is so necessary.
Absolutely. The baseline, of course, is compliance. You have this extremely robust regulatory framework in New South Wales, the EPA regulations, the Building Code of Australia.
But where's the technical spotlight landing right now? What's the hot-button issue?
It remains focused and really squarely focused on cladding inspections. And this is not just some tedious compliance paperwork.
No, it's a direct response to some catastrophic global failures.
Exactly. When you think about the horrors of the Grenfell Tower fire in London or the La Crosse apartment fire right there in Melbourne, the stakes are... well, they're existential. These inspections are essential because they actively mitigate that kind of catastrophic risk.
So they ensure legal compliance for the owners, but they also literally safeguard public safety.
By finding hazards early, yes.
Okay, so we've covered catastrophic physical failure from accidental causes like fire. Let's widen the scope to intentional acts. We'll shift from fire safety to site security with Amir Hussein's dive into crime prevention through environmental design, or CPTED.
CPTED is just a phenomenal concept. It's all about using deliberate design choices, the physical layout of a space, to reduce opportunities for crime.
And to maximize the chance of what's called natural guardianship.
Exactly. It was coined way back in 1971 and then formally recognized in New South Wales in 2001.
Can you walk us through its evolution quickly?
Sure. It's usually defined by 3 generations. The first generation was purely about physical design elements, effective lighting, controlled access points, good surveillance sight lines, fencing, that kind of thing.
Pretty basic stuff.
Right. Then the second generation matured the concept by bringing in the social and community aspects, how people actually interact in the space. And now the third generation integrates sustainability and public health outcomes alongside security.
So what's the big problem in the industry that Lote is highlighting here? Because the sources point out that a lot of CPTED reports are, frankly, pretty ineffective.
That's the critical and kind of shocking insight. A huge number of these assessments are generic, the template-driven, and they just lack the necessary empirical foundation.
I saw a number in there that was pretty staggering.
The study they cited showed that only 49% of reports even bother to use crime statistics. And even when they do, the data is often too general to make a real difference to the design. If you don't know what crimes are happening when and where, how can you possibly design against them?
So if these generic reports are useless, what does a best-in-class risk-based methodology actually look like?
It has to be comprehensive. Lote's approach integrates a deeper view of local crime statistics. They use crime mapping tools to identify hotspots and patterns. They don't just look at the total crime rate, they look at the type of offense.
It's more granular.
Much more. They use the detailed NSW Police CPTID checklist, and most importantly, they actively mark up the architectural plans to flag specific vulnerabilities that often get missed, things like dark blind spots, overgrown landscaping, creating hiding places, or, ambiguous entry points that just invite trespass.
It shifts the focus from a bureaucratic template to a really tailored security solution.
That's it.
That makes perfect sense. All right, let's pivot sharply from fixed design problems to the dynamic emerging fire risks that are driven by this global push for decarbonization and electrification. This is where innovation introduces entirely new dangers.
This is exactly where technological change creates new hazards we need to learn to manage and learn very, very quickly. Samir Hassan's research looks at the fire safety of electrofuels, or e-fuels.
And these are synthetic fuels, like e-methanol or e-ammonia.
Correct. And they're essential for decarbonizing these massive sectors that just can't run on batteries. Think heavy shipping, aviation. They're synthesized using captured CO2 and hydrogen.
So we're dealing with the energy of the future, but the production process itself sounds, it sounds inherently severe.
It is. The synthesis requires highly pressurized, high-temperature systems, and they use extremely toxic and flammable gases.
Like hydrogen.
Take hydrogen. Its flammability range is enormous, from 4% to 75% concentration in the air. It has incredibly low ignition energy, meaning it can ignite with almost no spark.
And the thing that always blows my mind about hydrogen is the flame itself.
It's almost invisible. That makes leak detection an absolute nightmare and firefighting even more complicated. And then you have ammonia, which carries the high pressure risk of a BLEV.
A boiling liquid expanding vapor explosion.
Yes, if containment is breached and that liquid rapidly vaporizes, it's catastrophic.
You mentioned mitigation requires a reliance on standards and engineering controls, and that's where the technical acronyms just fly. You list NFPA standards, but also HAZOP, LOPA, and QRA. For our listener, can you slow down and simplify what those critical controls actually do?
Absolutely. We can't just rattle off acronyms when the risks are this high. HAZOP, that's a hazard and operability study, is basically a very rigorous, structured brainstorming session. It's designed to identify potential hazards and operational problems really early in the design phase.
Okay, so that's step one.
Then Lote, or layers of protection analysis, takes those hazards you've identified and assesses whether your existing safety layers, your alarms, your pressure relief valves, that sort of thing, are actually sufficient to reduce the risk to an acceptable level.
So HAZOP finds the problem. OPA checks if the solution is strong enough. What about QRA?
QRA is quantitative risk assessment. This is crucial for new or complex risks like electrofuels. It's basically mathematical modeling that looks at the likelihood of an event versus the consequence of that event.
So it gives you a number.
It gives you a numerical probability that a leak or an explosion will happen, which lets engineers prove to regulators that the facility meets these really strict safety targets. Without these tools, building a hydrogen plant would be impossibly risky.
That context is vital. Now, let's see similar risks applied to transport infrastructure, specifically Yamin Ahmed's work on EV bus depots. Australia's public transport is shifting to electric at speed, and the central hazard is still the lithium-ion batteries.
The term everyone needs to know is thermal runaway. It's this unstoppable self-heating chain reaction within the battery pack.
And it's usually triggered by damage or a fault or overcharging, right?
Most commonly overcharging, yes.
But when it happens, the severity is just staggering. This is not a regular fire.
No, not at all. Temperatures can soar past 600 degrees Celsius in a matter of seconds, but actually worse than the heat is the toxic gas profile.
What kind of gases?
The thermal breakdown releases highly dangerous substances like carbon monoxide and hydrogen fluoride. Plus, unlike a diesel fire, these battery fires are notorious for reigniting days later, long after they appear to be out. It requires a whole new mindset for emergency response.
So what does a modern, safe EV depot look like? You're talking about a holistic, performance-based design, which means smart infrastructure and smart operating procedures.
Exactly. It starts with the physical design. Smart layouts that ensure you have enough separation between buses and charging bays. Then, intense early detection using tech like thermal cameras and specialized gas sensors.
And the sprinklers are different too.
Yes, suppression isn't about standard sprinklers. It requires specialized, high-volume, water-based sprinklers meeting specific Australian standards like AS 2118.1 and 2118.6, designed not just to put out the flame, but to rapidly cool the adjacent battery packs to stop the thermal spread.
And the operational side is just as critical.
It is. The battery management systems, the BMS, are essential gatekeepers. They're programmed to prevent the overcharging that's often the trigger for runaway. And you see a reflection of the risk in the fact that many depots are now actively preferring lithium iron phosphate batteries, LFP, over nickel manganese cobalt and MC.
Just because they're safer.
Simply because the LFP chemistries present a significantly lower fire risk.
We've transitioned from physical architecture to emerging energy risks. That brings us to our final section, the convergence of cyber and physical threats affecting our national security and critical infrastructure, as explored by Lana Vedikovich and Dr. Mara Maghrabi.
And the stakes here are, well, they're the highest possible. Critical infrastructure, or CI, you're thinking water treatment plants, power grids, major transport links. These are systems whose failure would catastrophically impact the nation's security and its economy.
And they're being targeted.
They are. The article cites concerns raised by ASIO about sophisticated state-sponsored actors actively probing and targeting these specific sectors.
The legislative response in Australia is the Security of Critical Infrastructure Act 2018, the SOCI Act. And this isn't optional. It mandates a Critical Infrastructure Risk Management Program, or CIRMI.
Right, and the CRP is an all-hazards program. It recognizes that a failure can come from anywhere, so it forces these entities to rigorously manage risks across 4 vectors: cyber and information security, personnel hazards.
That's insider threats or even just human error.
Exactly.
Yeah.
Then supply chain hazards, compromised hardware or software, and finally, your traditional physical and natural hazards. It's comprehensive because a failure in one seemingly isolated area, like a compromised HVAC system, can cascade into a national security incident.
And this legislation has serious consequences. The detail you highlight about civil penalties is crucial, but we need to put it into context. What does failure to submit an annual CRMP report within 90 days, resulting in 150 penalty units, actually mean to the listener?
It means massive, painful financial liability. We are not talking about a slap on the wrist. A single penalty unit in Australia is a specific dollar value, and 150 of them represents a significant civil fine that runs into tens of thousands of dollars.
Just for failing to submit documentation.
Just for that. And that level of penalty shows you the legislative urgency. Government sees this as a high-stakes compliance issue, and organizations need to treat CRMP documentation with the same rigor they treat managing hydrogen fire risks.
That sets the stage beautifully for the sheer scale of the digital threat landscape, covered by Farjad Mahmood on IoT security. The SOCI Act addresses the major targets, but the perimeter is blurring because of the Internet of Things.
Exactly. The numbers are just staggering, and they're constantly growing. We're dealing with over 27 billion IoT devices deployed right now. Everything from smart thermostats to security cameras, and projections are hitting 40 billion by 2030.
And those devices are facing an average of 820,000 hacking attempts daily. Wait, 820,000 attempts a day? That number alone should terrify anyone responsible for network security. What's frightening is that these huge threats often boil down to really simple negligence, right?
That's the lesson from the history books. Take the Mirai botnet, which happened years ago. That malware didn't need some super complex exploit. It just exploited the default usernames and passwords in consumer cameras and routers.
And built a massive botnet.
A botnet that successfully took down major web services like Twitter and Netflix.
Or more recently, the Verkada breach in 2021. That wasn't some sophisticated foreign intelligence agency.
No, it relied on a single point of failure. One super admin credential being compromised. That allowed attackers to view live feeds from over 150,000 security cameras.
In sensitive sites, too. Hospitals, schools.
Even prisons. It vividly illustrated the massive risk that comes from consolidating privileges over these cloud-managed IoT systems.
So if the proliferation is inevitable and the negligence is common, what does this massive problem require in terms of protection?
It requires a fundamental shift to a zero-trust mindset. You have to treat all devices, especially IoT devices, as untrusted by default.
So what does that look like in practice?
It means enforcing unique credentials for every single device, using strong encryption like mutual TLS or MTLS to protect data in transit, and rigorously implementing network segmentation using VLANs or microsegments to make sure that if one vulnerable security sensor gets compromised, the attacker can't move laterally across the entire corporate network.
Wow. We have traversed a huge amount of ground today. I mean, from ensuring the physical safety of cladding and implementing crime prevention on site to managing the explosive risks of hydrogen and EV batteries, and finally fighting legislative battles against state-sponsored actors and cybercriminals targeting the 40 billion devices connecting us all. It's a holistic, almost overwhelming view of modern risk.
It is, but it's an essential one. And as Dr. Mugrabi closed his message, thanking readers for their trust and wishing everyone a safe and restful holiday season, he implicitly underscored the core issue. That trust is earned because the risks we face, whether it's invisible hydrogen flames or invisible state-sponsored actors, are becoming faster, more toxic, and increasingly difficult to detect.
So if we connect all these sources back to that initial tension you mentioned between technology and human expertise, what's the single biggest challenge organizations are facing right now?
I think the real challenge is not the adoption of the technology itself. Innovation in e-fuels, AI, IoT, that's going to happen whether we like it or not. The true hurdle is maintaining the human rigor and the compliance culture that's necessary to manage these highly complex automated systems.
It's the human element.
It's always the human element. We've seen the penalties for CERM noncompliance. But even more devastating are catastrophic safety failures like the Imperial Sugar explosion in the US, which was purely the result of systemic human process failures, not technology breaking down. If continuous innovation is central to the mission, the stability of the whole system relies on human discipline keeping pace with machine speed.
Which brings up an important question for you, the listener.
Exactly. What processes are you reviewing right now to ensure human discipline is keeping pace with automation before the next invisible risk escalates out of control?